Here we want to find the area of a triangle, OAB, where we've got 2 points in three-dimensional space. So point A is -1, 0, 2, and B is at 0, 3, 2. Okay, so how do we break this question down into something that we can work with? We want area. Now, the only work we've done with vectors where we've calculated area is the cross product. And we know that A crossed with B is the area of the parallelogram formed by A and B. So if we've got, well, actually that is the area of the parallelogram, because A cross B is another vector. So if we've got vector A and vector B, then those two sides, if we drew another one parallel to B out here, another one parallel to A out there, we've got the area of that parallelogram. So, but we want the area of a triangle, and so a half A cross B will be the area of the triangle. So if you've got A and B, it'll be just that, which is exactly half of, if I drew the diagonal through there, it'll be that one there. So here is my point O. And so we've got to actually think that when we want area, we're thinking of the cross product. If we want a triangle, we put a half outside. If we want a parallelogram, we put A cross B. It may be helpful to spend some time to actually go and see what point A and B look like when you put them into three-dimensional space. Now, I've done it slightly different to your notes, and I've put X, Y in a normal spot, and Z will come out here using the right-hand rule. Z will come out here. I've actually plotted point A, I've plotted point B, and O is the origin. And so if we were to draw the triangle, we've got A and B. So there's my vector A, here's my vector B, and we are endeavouring to calculate the area of that three-dimensional triangle. So we've got vector A will be equal to, from the origin to A, which is a position vector, and that's given by -1i plus 0j plus 2k, and we can simplify that a little bit as just -i plus 2k. Likewise, vector B is equal to the position vector from the origin out to point B, and that will be equal to 0i plus 3j plus 2k. Once again, we can simplify that. 0i is, we don't have an I component, so that'll be 3j plus 2k. So we want a half the magnitude of the cross product. So let's just work out what A cross B is first. A cross B, we'll do it one step at a time, is equal to, from work previously done, we put I, J and K. We put our components of the A vector, and that'll be -1. There is no J, so that'll be 0, and there is a +2. And the B vector is 0, 3, and 2. Now, we put a plus, minus, and a plus above the first line. So that'll be I will be 0, 2, 3, 2 minus j. These should be straight lines. We want the determinant of these matrices. 0, 2, 3, 2, and then the j is -1, 2, 0, 2 plus k. The determinant of -1, 0, 0, 3 equals I. Now the determinant of this will be 0 minus 6 minus j, -2 minus 0 plus k, -3 minus 0 is equal to -6i plus 2j and minus 3k. Okay, so the area of the triangle OAB will be equal to a half the magnitude of this vector. So it'll be half the magnitude of minus 6i Now the magnitude of that vector will be equal to the square root of -6 squared plus 2 squared plus -3 squared. So it'll be a half the square root of 36 plus 4 plus 9, a half square root of 49. Square root of 49 is 7, and a half of 7 is 3.5 square units. Alright, so there's an application of the cross product. Whenever we see area, we think of the cross product or the vector product, the magnitude of the answer, and if we're asking for the area of the parallelogram, it is just the magnitude of the cross product. If we're after the area of a triangle, it's exactly half of that. And we use our rule here once again for the cross product using matrices, and there it is.